If there are lazy lists, then there are also lazy grids. And they are exactly what you think they are. While a lazy list, a lazy column would just have one list item per row of it, with a lazy grid, we're able to build a grid. So a lazy grid is really the same as a flow row, just that the lazy grid is also able to scroll vertically and only load the composables that are actually visible. So I would say, let's just try out how this would look like here in code. We have a lazy vertical grid. There's also a lazy horizontal grid, and there's also a lazy vertical and horizontal staggered grid. Let's start off with the lazy vertical grid, which also gives us this block of code here, where we can then also, just like for a lazy column, call item, items, or items indexed. Here, a sticky header wouldn't make sense, so we can't use sticky header, but we can very well use some sort of items. So let's say we have 100 items again. Let's use simple colored boxes here to make this clear on what this is useful for. Give this a modifier, maybe with a size of 100 dp, Alt-Enter to import dp, and then give this a background color that is random again, so we can just construct a new color value, and the integer that the color int we pass in here is just randomly generated, so random next int. Then you can see it definitely needs a required parameter. Let's take a look what that is. It is this columns parameter. So we need to pass in this grid cells value, because depending on how our grid should look like, we might want to have a different rule for how this grid and how each row, or how all these composables inside the grid should be split in the row-like fashion. I think let's just go through this, and this will make it the clearest. We can pass something like grid cells fixed size, fixed, or adaptive. The easiest to understand is simply fixed, where we can say we want to have 5 columns in our lazy vertical grid. And then if we take a look on the right, that's exactly what we get. So the lazy vertical grid will now take this column count of 5 and use that to assign that kind of width to the child composables that exactly 5 of them fit into a single row. So you can see there are 0 gaps between these elements. They fit perfectly. And if you would make this a column count of 6, then this would also fit perfectly, but we would just have 6 of them per row. And you can also see here, this is really the same type of concept as for the flow row. So these colorful boxes could also just be our chips, and when a chip doesn't fit into this row anymore, it would simply jump to the next one. But with the difference that with a lazy vertical grid, we can actually also scroll horizontally here. So if we enable the interactive mode again, you can see we can scroll through this grid, which is a little bit laggy here, but this is only for the preview. And you can also notice that the actual width value we assigned to this box, which is 100 dp, since the size modifier adds this for both the height and the width value is simply ignored, or rather overridden, by the lazy vertical grid, because you can see these composables, these boxes are all higher than they are wide, even though we assigned them a size that would normally make them a square, but actually doesn't, since the lazy vertical grid will figure out the width for us. So we can as well just set this to height, since the width will be figured out for us. Let's take a look at what else kind of grid cell options we have here. So we have grid cells fixed, which we've explored. We now also have fixed size, where we can say, okay, this is actually the amount of dp these boxes here should be wide. If we pass something like 100 dp in here, and we say, okay, every box should be 100 dp wide, please fit in as many boxes with this width into a single row. And if that doesn't fit anymore, make it jump to the next row. So really similar to what we've also seen with the flow row before. And what's interesting is we have this adaptive option. So here we can pass a min size. So here we don't really pass in a fixed size where we say every single box in this lazy grid should have exactly this width. No, here we can actually say every single box should at least have that kind of width. But if certain boxes have a larger width, then please use that. So if we say 50 dp here as a minimum size, and we then say we give this box actually a fixed width, but the width is randomized again. So something like random.next int, and we actually give it a range of values that we can generate here, something like 1 to 200, and then say .dp to just transform this random value to dp. Then every single box now inside of our grid will at least be 50 dp wide. But as you've seen, if we actually give this a fixed size as before, so fixed size of 50 dp, then unless our screen width is perfectly divisible by 50, there will always be some sort of gap here, since the last element doesn't fit in there anymore. If we use adaptive, then you can see it will always fill the whole width of our grid while giving all these grid cells a width of at least 50 dp, but it will dynamically increase that so that we're still able to perfectly fit our boxes here into a single row, so that the whole width is simply filled. So those are already the 3 core column settings, column configurations we can assign here to a vertical grid. Of course, there's also a horizontal grid, which would then arrange these in a horizontal fashion. Again, similar to a lazy column and a lazy row, the vertical grid is used more frequently here. So you can think of this like, I don't know, an image gallery or so, what this could be useful for here. But we're also not done yet here. So just like for all the other layouts we've covered before, except for a box, we can also pass in things like a vertical arrangement. So we could say we want to have some spacing between these single grid cells. And you can see all of these have 16 dp of vertical spacing. We can do the same horizontally. So here, just like for flow rows and flow columns, we can use arrangement values for both horizontal and vertical directions. So we could say, okay, we have an arrangement dot spaced by 16 dp as well. And then we have exactly 16 dp of spacing between every single grid item in all dimensions. But of course, all the other arrangement values here also apply. I don't think I need to go over that again. I think at this point you've understood this quite well. Let's take a look at what else we can do here. So we certainly have the content padding, just like for a lazy column, which will just give our grid some padding. We can also pass in a lazy grid state, just like for a lazy column. We can use this to control or programmatically just scroll in this grid. We can observe certain scroll states with this state. We can also set user scroll enable to false if we don't want them to scroll. But that's pretty much already it. So it's very similar to a lazy column, just that we have more than one element in a single row. But what's interesting is that there is not only a lazy vertical grid and a lazy horizontal grid, but also, as you've seen before, a lazy staggered, lazy vertical staggered grid. So the difference between a lazy vertical grid and a lazy vertical staggered grid is that with a lazy vertical staggered grid, the items, the grid items or boxes here are able to actually have varying heights. So if we actually get started with that, let's get rid of that. And here we also need to pass in this columns parameter, but this time it needs to be of type staggered grid cells, dot fixed, for example, if we pass in 5. And right now, this looks very similar to how it looked like for the lazy vertical grid. But if we now give our boxes actually varying heights, so we take this width value, or this random rather, and assign it for the height. So the boxes have different heights, something like this. Then you can now see this is how such a staggered grid looks like. Now our boxes have differing heights, but they are still displayed in this grid-like fashion. So I'm pretty sure you know these kinds of feeds from, I think, Pinterest, for example, uses such a staggered grid. If you just have a big feed of photography, of maybe inspiration about furniture design, I don't know what kind of image video feed you're building, but for these types of feeds, such a staggered grid can really help. And then, of course, we can also again go into the interactive mode and scroll here. That works perfectly fine. If we take a look in here, are there any other special parameters that we wouldn't be able to pass before? Yes, so we can pass a vertical arrangement here for a staggered grid, but we can give each item vertical spacing. So if we want to achieve the same as before, we would use the vertical item spacing, and then we have this effect here, as you can see on the right side. And then I think another cool effect would be to give these boxes here rounded corners. So you really have that social media feed feeling by just saying you want to clip this box to a rounded corner shape and saying we give it a border radius of 10 dp. And then you can see this looks pretty cool, I think. So we'll of course get more into modifiers and why it matters that the clip is here and not after applying the background. But so far, that is how you can build grids in Jetpack Compose. And of course, it's, again, the same lazy loading behavior as we've also learned with lazy columns, lazy rows. So right now, only the visible items would actually be composed in our UI hierarchy.